Hey y'all, welcome back. If you haven't watched my ramble, y'all watch that so you can get caught up on everything else. I'm going to get right into the lesson. We are going to be working on volume today. Now, to find the volume of any prism or cylinder, any of those, you're going to be doing big B times height for all of them. Now, this is going to break it down and kind of give you a little bit more specific, but that big B stands for the area of the base. And remember that the base is going to be the shape that is like identical to itself, top and bottom. So if you're looking at a rectangular prism, your base is going to be like the bottom and the top, just like a cereal box. The base is there. So if we're looking for the volume of a cereal box, we want to know how much like water we could completely fill inside of that cereal box. So what we're going to do is we're going to take the area of the base and we're going to multiply it times the height. Well, the area of the base is going to be length times width because that's a rectangle. So really for this one, we have length times width times height. And that's pretty much how we have that one memorized. So if you're looking for the volume of a rectangular prism, you're doing length times width times height. Now, does it really matter who's who? Not with this one. It's not really going to matter. But you could say this is the length, this is the width, 24 is the height. Then you're just plugging it in. Volume equals 9 times 17 times 24. You multiply those together, that's 3,672 centimeters cubed. That is new. Everything that we've been doing so far has been squared, but since this is volume, it's going to be cubed. This one, same thing, you're just doing volume equals 10 times 14 times 4.5. Now, those may not be specifically who's the length, width, and height, but since we're multiplying, it's not really going to matter. 8 times 12 times 39. Just that easy. Okay? Now, here we are with the other prism. So we're back to that big B, where big B stands for the area of the base. So this is going to be a little bit more important who is actually your base, because your height is going to be what separates those two bases, the distance in between your bases. So if we look at this one, you can see that you've got some triangles, you've got some rectangles. So what are my bases? Well, the base is going to be this triangle and then the one directly behind that triangle. So that's not a right triangle, but you can see through the middle of it, they have labeled the height 7.3 of that specific triangle. So for my volume, that big B is going to be a triangle. Now, how do we find the area of a triangle? 1/2 the base of the specific triangle times the height of that specific triangle. And then this H stands for the height of the prism, which is the height between those. So these two numbers are probably not going to be the same. This is all for the triangle. Okay, so don't let that be confusing to you. Okay, so here we go. This is going to be 1/2. The base of this one is going to have to match that 12. So the base here is going to be 12 times the height, which is the 7.3. Now that is all for the big B. That is the area of the base. Now, between those two is here, here, and here. Those are all the heights. That 10 represents that side. We don't need that information. It's just extra. It's there to kind of distract us. What we need is that 5. Okay, so that 5 right there is going to tell us that that is the height of the prism. Okay, all right, so then we just multiply those things together. 1/2 of 12 times 7.3 is 43.8. And then we're multiplying all of that times 5, which equals 219 feet cubed. Okay, I'm just trying to make things go quicker, so I've done the math already, so I'm just giving you those answers. But you would just plug that into your calculator, okay? Again, for this one is a triangle base. If this is too confusing, seeing everything written out like that, try just starting with your big B by itself. So here we are again. You have a rectangle, maybe a square. This one's different. If they're different, y'all, they cannot be your base. Your bases have to be exactly the same. So these are going to be my bases. And that 5.4 right there represents the height of that triangle, and 11 represents the base. So I'm just going to have 1/2 the 11 times 5.4. So you could just do that by itself and find the area of the base. That is going to be 29.7. So then you find the volume, big B, times the height. Big B is 29.7. The height is going to be what's in between. Okay, so those orange ones that I just did, orange, orange, orange. So that is going to be 16. So 16 is the height. You multiply those two things together, that gives you 475.2 millimeters cubed. Okay, this one's a little bit different. It's not a triangular base. It is a trapezoid. So we have short base, long base. We have our sides, and then you have your height right there. Okay, so that is going to be our base. So let's just do big B. We won't deal with the height just yet. Big B is going to be 1/2 the height of the trapezoid, base 1 plus base 2. Hopefully you're getting those memorized so you're more and more comfortable with that. So 1/2, 17.9, base 1 is 14. This base is going to have to match that 36. So that's going to be, is it plus? Yeah, plus 36. I just forgot just that quick. Multiply all that together. That's going to give us 447.5. Okay, so that's my big B. So to find the volume, I need the area of the base times the height. So that's going to be 447.5. The height connects my bases, which is this 25. So I'll multiply those two things together, and that is going to give me 11,187.5 meters cubed. Remember that volume is cubed. Got it? So that's when your base is a trapezoid. Okay? This one's back to a triangle. Number 7. It's back to a triangle, but we don't have all the pieces that we need. So this is a right triangle, which means your legs are going to be your base and your height, not your hypotenuse. So you have to find the base. You know that the height is going to be 28, but we need to find that base. So we're quickly going to do the Pythagorean theorem. Our a squared plus b squared equals c squared. So a could be 28 squared plus b squared equals the hypotenuse, which is 32.5 squared. We're going to subtract out 28 squared from 32.5 squared. So I'm just, again, being kind of lazy and not doing that math, letting the calculator do that. That's going to give me 272.25. Then I'm going to take the square root of that, 16.5. So that base is going to be 16.5. Okay, so now that you know that is 16.5, you're going to do the big B, which is 1/2 the base, which you just found, times the height, which was given. Okay, so that is going to be 231. So your volume is going to be big B times height. The big B is 231. The height is what separates your bases. The distance in between those bases, which in this case is 31. You multiply those two things together, 7,161 kilometers cubed. Okay? This right here is another trapezoid. So again, you're going to have to find big B, which is going to be half of the height of the trapezoid, base 1 plus base 2. For our trapezoid, it's a 90-degree angle right here, so this is going to be my height. It doesn't look like they gave us that. But they did give us our 2 bases, so we can find that, I guess. Yeah, we'll just have to draw that little triangle. So I'm going to kind of do this over here. So I'm going to draw this here, you guys, because I need to know the distance there. So I know that this is 25, and this entire thing is 35. So if I'm sorry, what is it? 39.4. Okay, 39. Sorry, it's this 39.4. That 35 separates those 2 bases. So 39.4 is this. So what I need to do is I need to subtract. Yeah. Okay. 39.4 minus 25. That's going to give me 14.4. Okay. They also told us our hypotenuse is 30.6. So we need to find the other leg. That's what we're looking for. So again, we're going to do the Pythagorean theorem. 14.4 squared plus x squared equals the hypotenuse, which is 30.6 squared. I'm going to subtract that. So I've got 30.6 squared minus 14.4 squared. That's going to give me 729, and then I'm going to take the square root of that. So you're just doing the Pythagorean theorem. I'm just doing that quickly. So that tells me that this is going to be 27, so that's going to be 27. So the height is going to be 27. We found that using our Pythagorean theorem. Okay, so that's going to be the height of the base, 27. Base 1 would be this 39.4 plus base 2, which would be this 25. Okay, so then we do that math, and that is going to give us 869.4. That's the big B. So volume equals big B times height. Well, big B is 869.4. The height of the prism, not the height of the base, the height that separates the 2 bases, is 35. You multiply those together, and that's going to give you 30,429 centimeters cubed. Okay. All right. The next 2, these are cylinders. Even though it specifically tells you pi r squared, that's still B. That's how you find the area of the base. The base of this one is a circle. To find the area of a circle, it's pi r squared. So again, it's still the same exact formula. It's just changed it just a little bit and gives it to you specifically. All right, so pi, the radius is 18 squared times the height, which is 15. You just plug that into your calculator, and that gives us, well, I do want to show you this. Sometimes your answers, especially on ACT, will be in terms of pi. So if that's the case, it's going to be 18 squared times 15, which is 4,860. And then you just leave pi there. So if your answer says, what is the volume in terms of pi, that's what that means. Then you leave pi there, okay? Now, if it wants specific, if it wants the actual volume, then you would either use your pi button or you would use 3.14. Now, you do see that you get a bit of a different answer. Okay, so that tells you how much rounding is involved when you're using the pi button times 3.14. So that's why on ACT, a lot of times they will say in terms of pi, because everyone should get this answer, regardless of how fancy your calculator is. So make sure you do pay attention to that. So I'm going to put it in 15,268.14. I'm going to use the pi button, but if you use 3.14, then you'll see yours is going to be kind of different, pretty different. So make sure you're paying attention to that. Okay. For this one, they gave you the diameter, so you have to take half of that. Half of 11 is 5.5. So then you're just doing volume equals pi times 5.5 squared times 21. Okay. Now, application. Down here on the applications one, it says a cylinder with a 2 centimeter diameter is drilled through a triangular prism shown to the left. Find the volume of the prism. So what we have to do is we have to find the volume of the triangular prism and then subtract out the cylinder. All right, so here we go. The volume of the triangular prism is going to be big B times height. Big B is going to be 1/2 the base times height. So 1/2. This is a right triangle, so we're looking for the legs, a leg of 5 and a leg of 5. So that's just going to be 5 times 5, which is 25. Half of 25 is 12.5. Okay, so that's big B. So we come back over here. Big B is 12.5. The height that separates those two things is 14. So when I multiply that together, that gives me 175 centimeters cubed. That's the volume of the whole thing. Then we're going to find the volume of the cylinder, which is pi r squared times the height. So pi, it has a diameter of 2 centimeters, so the radius is 1 centimeter, and the height is still going to be 14 because all of that's stuffed together. So we have pi, I'm going to use the pi button, 1 squared, which is just 1 times 14, and that's going to be 43.98. So that's the volume, and that's still going to be centimeters cubed, and then I'm just going to subtract. Okay, so 175 minus 43.98 is going to give me 131.02 centimeters cubed. All right. This one says the diameter of Eric's pool is shown to the left. He plans to fill the pool to the depth of 4 feet. So it's 4.5 is what it's made, but he only wants it to be 4 feet with a garden hose that has 80 feet per hour flow rate. How many hours will it take to fill the pool? So we're going to just take half of 27, which is 13.5. We're going to use that as our radius. So pi times 13.5 squared times the height, which we're using 4, because he's not going to fill it completely, just to the 4. So I'm going to type that in my calculator. Pi times 13.5 squared times 4, which is, this is how much volume we need. Well, then we're going to divide it by the 80 because that's how much our water hose can do per hour. So that's 28.63 hours. So it's almost going to take over a day to fill that swimming pool up. Okay? That's it. That's volume. Pretty simple. You have homework to do tonight. Do your homework. Make sure you turn it in for volume. We will have a quiz this week. I believe it's going to be Friday, but I will make sure I post that once I'm certain. All right. Glad you're back. Missed you.